morning or good afternoon. Today we are discussing Chapter 2, Lesson 2, Angles to Angle Triangular Similarity. So I have a video from the book. I thought that would explain things better than I could with the tools that they have. With they'll have a lamppost and a person, and they show casting shadows. This is real life. You will do this, especially if you take trigonometry. You will be doing these type of problems. So if you're planning on doing that upper level education, you're going to have it. Or you'll have to understand how to do this. So make sure you pay attention to that video. It's a very good video. It explains things about how these are similar triangles and how they are proportional. Now, it doesn't say anything about this, but just pay attention to the video, how to do it, and then we're going to discuss this, and then in the next section of the video after that, we're going to discuss what makes a triangle similar. Alright guys, so when I did research, which I did do research, I researched before I teach, I saw several problems like this, and it's similar to what you just watched about the video on the light bulb. The only difference is that this doesn't have words with it about casting shadows. Like you could draw a little person in here and be like, that's a whatever, you know. All right, so these are considered similar triangles. We have one big triangle, and then if you ignore the line, it's a big triangle, and then we have a smaller triangle, and they're similar, okay? So if this side is question mark, this side's question mark, right? We don't know what this side is. Now, we've got to set up a proportion because we want to find out what the question mark is, all right? Now, personally, as myself, and myself is different than all of y'all, so you could do it this way or you don't have to. I like to do small to big. That's just how I like to do it. I like to do small shape on top and the bigger shape on bottom. That is just personal preference. You do need to pause this video, get scratch paper, because you need to work these out. Yes, you can use your calculator, by the way. Shout out to Ray. I'm borrowing his. He left his here on the charger, and I personally don't have one myself. So thank you, Ray, for sharing your calculator with me. And by the way, I know Jackson's going to be asking, Ms. Mitchell, is this the one I interrupted you? He just interrupted me and dropped off a bunch of calculators. And I was in the middle of recording, so I had to stop because he was banging on the door. So thanks, Jackson, but it's okay. All right, so I like to do small to big. Pause, get scratch paper. When I've seen examples online, different places I go to do my research, I've seen where they don't do small to big. They do the line labels. So they would do like DC. This is my smaller triangle. So that's DC, and my smaller triangle is this side that I do know the measurement of, which is CE. So DC is equal to CE. My small ones are on top. And then the corresponding or the proportional side for DC is BA. So that's going to go under because I got to keep my likes together. I'm keeping my likes together. This is alike. This is alike. This is alike. So this is alike, right? So it doesn't really matter which side you want to do. We can do AE because we did CE, so we'll do AE. All right, now, underneath it, I'm going to set up my proportion. And we know this equal sign right here that we know from, if you think back to, I know I taught it in 3rd grade, comparing fractions. All right, so when you compare fractions, we cross multiply. Remember we did the butterfly it, butterfly it, butterfly it. And I had most of you in 3rd grade. And that's how I taught you guys. We'll do the butterfly method. We cross multiply. So what we're going to do is we know that AE times DC is going to be equal to BA times CE. Remember we would cross multiply, and if this was bigger than this was bigger, we would eat this one. So now we need to make sure they both are equal. All right, so now I'm going to replace them with numbers. Okay, so DC is 15. And the bigger version, BA, is 20. Okay, And we know that's going to be equal to 12 over, we don't know, and I'm putting an X because it's my favorite letter to work with when I'm doing algebra. Okay, so now we know that whatever times X times 15 is going to give me whatever. And it has to be equal to 20 times 12. They have to be equal. We do know that because, duh, there's an equal sign right there, right? All right, so let's set it up. Okay, so we'll start with this. We'll do 15 times X. So 15X is going to be equal to 20 times 12. Mentally, I know that 20 times 12, I'm just going to rewrite it because I can't divide by 15 over here and then divide by 15 over here and make it pretty. So I've got to, I'm just going to go ahead and multiply. So 20 times, because a lot of times it'll be like, you know, oh, I can divide by 15 over here and divide over here, and it's all gravy, but that's not how it works right here. So 20 times 12, yeah, I know mentally is 240. So what times 15 is going to give me 240? That's what I got to say. So right now, the only way to find it, so when I have this 15 touching the X, that is an invisible multiplication sign in there. So 15 times X is going to give me, I don't know, because I don't know, it's going to give me 240, whatever X is. But the way to get rid of this 15 is to do the opposite. Well, what's the opposite of multiplying? Dividing. So if I divide this side by 15, 15 divided by 15 is 1. Okay? And 1 times anything is itself. So that's invisible. I don't necessarily have to put it. If it makes you comfortable putting it, put it. Now, here's the golden rule in algebra. What I do to one side, I've got to do to the other. So since I divided this side by 15, I've got to divide this side by 15. And this is where our handy calculator comes in comes to help. So thanks, Ray. So I'm going to turn it on, and I'm going to type in 240 divided by 15, bam, 16. Okay? But I'm not done. I'm going to use 3 seconds of my life and make sure I got this problem right. Okay? And I'm going to do that by check yourself or you wreck yourself, girl. And how I do that is to make sure they're equal when I cross multiply. So I should have now 15 over 20 should be equal to 12 over 16. Let's check ourselves or we wreck ourselves, girl. So we know, let's see, we know that, 16, we'll just check, 16 times 15, even though I just did it, this is 240. And 20 times 12 is 240. They are equal, so I know 16 is my answer. I did it right. And that took 3 seconds to check my work. And I know it's right. And now I got it right. I know it's right. I checked it. All right? So, if you have questions on this, raise your hand so I can come help you. Don't just sit there and be like, I'll get it next time. No, you won't. Because, as you can see, third grade math is coming back to haunt us. So, you got to know now before you move on. All right? And I'm here to help. Okay, now we have to discuss what makes triangles similar. Well, first, you got to understand, let me run a color. McClatchy's staring at me thinking I'm crazy, and I am. Okay, first, you got to understand, so this triangle has the measure of 60 and 60, and we don't know this one. And we don't know this one, that's 60, and that one's 60. So we don't know this missing angle or this missing angle. So what you have, first, before you can tell if they're similar, you have to understand if you have a missing angle, how do we find that missing angle? Well, you need to know that, squares, all angles are right? All of these are right angles. So that means they're 90. 90, 90, 90, 90, right? And a square equals 360 degrees on the inside. All the angles add up to be 360 because all of them are right angles. They're all 360. But just like finding area of a triangle, we know that we have to cut these in half. We cut this in half, and we've got a triangle here and a triangle there, right? So 360 divided in half is 180. So each triangle equals 180 degrees on the inside because they're essentially half of a square or a rectangle, however you want to look at it. All right, so we have to figure out if the angles, the corresponding angles have to be congruent. They have to equal. All right, so we know this is 60, this is 60. We don't know what that is. So if we do 60, I'm just going to do all the steps. We know that this x has to be 60. Well, what's 60 plus 60? 120 plus x equals 180. And we have to isolate this x. So to get rid of the x, we have to do the opposite by subtracting 120. And what we do to the left, we got to do the right. And we get 60. So x is equal to 60. So this angle is 60. All right, now we got to find that angle. I think you know where I'm going with this. So we have 60 plus 60 plus x equals 180. 120, same thing. So these are going to be equivalent, right? They're going to be congruent, I mean. So x is equal to 60. These triangles will be similar because they have the same, their corresponding angles are congruent. Okay, so these are similar angles. So let's try one more example because I feel like I've kept you long enough today. Okay. One more. Okay. I'll do a big right triangle. And then a little baby right triangle. So we know these are 90. They may not even give you 90. And let's do 45. And I'm going to do 30. 30 there. So we don't know this angle or this angle. Okay, now we know this is 90, right? So we can find those missing angles by adding all this up and see if it equals 180. So I'm going to start here. I'm going to make this x. Sorry, I'm going to make these x because I like working with x's. All right, so we have x plus 90 plus 45. That has to add up to be 180. All right, and then if you want to use your calculator, use your calculator. So we have x plus 235, I think. No, I'm being stupid. That's fine. This is a plus. So that should be 135 is equal to 180, I think. Right? Did I do that right? Double check. Do that in my head. 45 plus 90. Yep. Okay, so I've got to subtract 135 here and subtract 135 here, and that becomes 45. Okay, so x equals 45. So right here, that angle is 45. Is that angle 45? No, it's 30. But let's just go ahead and solve just to double check. So our next one is 90 plus 30 plus, we don't know, equals 180. 90 and 30 is 120 plus x, 180, 180, minus 120, minus 120, and x is equal to 60, right? So those are not congruent. Those would not be considered similar triangles because their corresponding angles are not congruent. Okay? So if you have questions, ask me.